Okay, so welcome to Demonstrating Implementation Excellence stream of the SNOMED CT Expo 2024. Thank you to FAST for sponsoring this stream. My name is Ian Green and I'm the Customer Relations Lead for Europe and also the Global Clinical Engagement Lead at SNOMED International, and I'll be moderating today's session. All questions will be answered at the conclusion of the presentation. For online attendees, please use the Q&A button to type your questions to the presenter. And on-site attendees, please use the microphone provided in the room. I'm now pleased to introduce Nicholas Seah from Synapse, who will be presenting Enhancing the Model of the Singapore Drug Dictionary. So Nicholas, please go ahead.
Hi, thank you. Just a brief introduction of myself. I'm Nicholas from Synapse, a health tech company and NRC in Singapore. Yeah, so today the topic that I'm sharing is enhancing the Singapore Drug Dictionary model. So this is the objective of my sharing today. The main objective of my sharing is actually to illustrate how SNOMED CT is used in the transformation of Singapore Drug Dictionary. Yeah. So before I delve into the details of the transformation, just let me share some background of SDD, just to let everybody familiar what SDD is. So Singapore Drug Dictionary is a national standard to unambiguously identify, code, and interpret medicine. So since the implementation of Singapore Drug Dictionary, all Singapore public health institution has adopted it, and they accounts for more than 80% of the hospital bed in Singapore. And they use primarily for the prescribing and dispensing purpose. Yeah, and to make sure that we actually code the exact medicinal products that is brought into Singapore, we obtain the information from the Health Science Authority, which is the agency that registered all the medicinal products. Yeah, so we actually create codes for all the registered product that is approved by the HSA. Yeah, so before I go into, so after you understand what is SDD, so just let me share the motivation for us to transform to a new model of SDD. So there are two groups of factors that motivate us, and one is the push factor, which is the drawback of our current SDD model. So the current SDD model is very complex because it's designed for multiple use cases, and with that, it has a very advanced complexity. And this advanced complexity result in three drawbacks, which is one is the extended publication cycle, because we have very there's a heightened challenge in authoring, and also there's many validation issues that need to be resolved, and that's why we have an extended publication cycle. And also we need large amount of effort in maintaining each publication cycle, because we need very sophisticated extraction rule to do data extraction. And even with that sophisticated rule, we cannot extract 100% accurate and consistent data. And that's why we need a lot of reviews to make sure that they are correct before we publish it. And also, like I mentioned previously, we have a lot of validation issue, and all these validation issue will require resolution. And for each resolution, we need to actually do a lot of testing just to make sure that it will not impact other unrelated data. And lastly, because of the advanced complexity, it takes a longer period of training to train new staff to reach competency before they can actually do our normal BAU operations. And then there's another pull factors, which is the benefit of the new SDD model. So we actually envision to design an SDD model that is simpler. And with a simpler model, we anticipate that it will have a shorter publication cycle, because authoring will be more straightforward and easier. And there will probably be less validation issue. And also less effort, as I mentioned. We will require a simpler, the data extraction will be simpler because we'll use a simpler extraction rule, and it will be shorter. Yeah. and there's no need to have any reviews because the extraction rule probably can extract 100% accurate concept. And also with less validation issue, we can have less effort to do the resolution. At the same time, the resolution will require limited or even no testing. Yeah, and lastly, because the new model is simpler and easier to comprehend, shorter training will be needed for newcomers to reach competency. And we feel that this is a good time for us to do a remodeling is because for the past 10 years of implementation, we actually gather user requirement, and this user requirement actually has stabilized. And because the requirement is not likely to change, so it's easier for us to do a remodeling based on this requirement. Yeah. And now let me just introduce some of the complexity of the current SDD model so that we can appreciate the impact that the transformation can bring about. So before we actually embark on our transformation, we actually do two things. We actually study the current SDD models to look at the area that we can actually improve to reduce the complexity. At the same time, to look at the user requirements over the past 10 years. Yeah, so we identify 4 areas of complexity. One is the core SDD classes. There's the container SDD classes, the variation of the SDD classes, and the use case layer. So I will actually explain each of these, not in details of the model, but how much complexity each of these area has been contributing to our SDD model. So I will touch on the core SDD classes first. So that there are 12 SDD classes with the highest level, MP and MTP, containing the list information and adding additional information after every succeeding level, with the NPPC and MTPPC containing the most information. With 12 SDD classes, it signifies that for every medicinal product that we have, right, we will have at least 12 concepts representing them. Yeah, when all information is available. The next area of complexity is the container class, container SDD class. So this container SDD class is an extension of the core classes, and they are only present conditionally. So as you can see in the diagram, the green boxes are all the additional container classes. So they actually add additional 14 concepts to the core classes, which means that for any certain product that has container classes, right, it will actually result in about 26 concepts representing them. And then there's 7 variation of from the core classes. This variation is the expansion of the core classes. And similarly to the container class, they are present only conditionally. So as you can see in the diagram, we have the 7 variation with emission product variation, total strength variation, and multi-subpack variation, contributing 10 concepts, 8 concepts, and 40 concepts per subspecs, respectively, to the complexity. And there's the multi-pack variation, and contributing 6 concepts per multi-pack size, multi-component variation, 40 concepts per component, and the with device variation as well as the basis of strength variation contributing 12 and 4 concepts per medicinal product, respectively. And the last complexity will be the use case layer. So we have 44 use case layer. So our use case layer is divided into 4 pivots, with the first 2 pivots that representing the dose form, ingredient, container, and device. So the ingredient that we have exists in multiple levels. So with the different level of the dose form, container, and device, it will have multiple combination, and this resulted in 11 combination. And with the last 2 pivot of the use case layer, which is the qualifier of the ingredient, and if there's presence of any other defining information, it resulted in additional 4 times more concept. So so the 11 combination and the 4 combination as a result resulted in 44 use case layer. And this means that for every SDD class, it potentially increased the number of concepts by 44 times, in addition to the side effect classes as well as the container classes. So I think it's a bit confusing. So I actually prepared an example to show you how all this contribute to the complexity of SDD model. Yeah, so this shows the core classes, the container classes, and the use case layer. And just to mention, this actually only show a partial picture of an actual medicinal product. So if you add more use case layer and more variation, it will result in a bigger complexity. So for this, just based on these three aspects, we actually have already 58 concepts. And if I were to add one more variation, it would add additional 42 concepts. So it resulted in 100 concepts representing one medicinal product of one pack size. And do we need so much concept just to represent one medicinal product? So for the past 10 years of our implementation, from the user requirement, we discovered that we do not need so many concepts because of our very focused use cases. So we only need about 10 concepts. And that's why we want to do the transformation. So next, I will actually talk about the transformation, overview of the transformation, our transformation strategy. And before I go into that, I will actually just show the new model that we are transitioning into. So just now I actually show you an example of the current model that has 100 concepts. And after transformation, we actually aim to just have 10 concepts. So we have 4 steps of transformation. So our transformation actually aim to reduce complexity and improve the performance of our current tool by reducing redundancy. And at the same time, we take our user requirement into consideration and also takes potential new use cases in the future into consideration. So what we do is we study the current SDD model and also the user requirements that we have for the past 10 years. And then we actually come up with this 4 steps of our transformation strategy. And the first step is to actually remove a use case layer, because we discovered that for each SDD class, there's only 1 or 2 use case layer being extracted. So we can actually remove the whole use case layer, and that will actually potentially shrink down our model tremendously. The next is to remove the SDD class variation. Some of our SDD class variation are not in use, so those that can be actually removed without any impact. And then there's one which is the administrable product variation. So for that, it's either the administrable product variation is being used or the core classes is being used, and not both. And that's why we can actually transfer this complexity to a description, and therefore we can actually reduce the number of concepts. And then the removal of side effect classes. So, the removal of the container side effect classes. So the container SDD classes actually is very similar to the core classes, just with the additional of the container classes. So we can actually use the core classes to represent these container classes. And at the same time, not both core classes and the container classes are used. So we can actually remove the container classes and represent them with the core SDD class. And lastly, the merger of 2 SDD core classes, which is the quantity SDD class and pack SDD class. So these 2 classes are very similar also, and they are used mutually exclusive, so we actually don't use them together. So that's why we can actually merge them together. Yeah, so now I will actually talk about each step of the transformation, the challenges that we face, and how we actually use SNOMED CT to overcome these challenges. So before I go into details, these are the SNOMED CT features that we use in terms to resolve the challenges that we face in each step of the transformation. Yeah, so for the first step of the transformation, which is the removal of use case layer, we actually encounter a challenge is that different use cases are being extracted for different medicinal products. And if we were to simply remove the use case layer, the easiest way actually is to just identify one use case layer and applies to all medicinal products. But we can't do that because, like I mentioned, different medicinal product uses different use case layer. At the same time, we can actually retain those use case layer that we use and remove the rest. But the number of use cases we use also is quite a lot. So it also doesn't, if we were to do that, it doesn't help with removing the complexity. So what we need is actually to find a unique set, a unique combination of attributes to be added to the concept, and that's why and therefore that remaining SDD, the remaining concept in the model, right, will be able to represent all different medicinal products. So as I mentioned, for my use case layer, there are first two pivots that result in the 11 different combination, and they are the ingredients, dose form, and container. So first we'll look at how we can actually find the correct level of ingredient, and that is to find the clinical relevant ingredients. So we actually will compare the active ingredient with the basis of strength substance. If they are different, if they are the same, then of course we no need to choose any of them because there's only one choice. But if they're different, we actually will look further into their attributes. So in SDD model, we have this attribute called whether they are clinically significant. So we compare the basis of strength substance and the active ingredient. If they are different, we'll choose the one that is clinically significant to be the clinically relevant ingredient. However, if both of them are clinically significant, we will choose the more specific one. So it's easy because for our active ingredient and basis of strength substance, right, they exist in the same hierarchy and they are arranged ontologically. So we can actually just based on that hierarchy and choose the more specific one. And for dose form, we would like to find the defining dose form. So we actually make use of ECL to subcategorize our dose form ref set into 3 different subsets. And then looking at the dose form that is entered in the source data, which is a form where we store all the information of a medicinal product, we retrieve the ancestor and self concept of the dose form and compare to the category that the dose form is in. And then we will look at the overlapping concept and find the most specific concept to be the defining dose form. So container and device is similar, just that we don't do the sub-categorization of the ref set. Yeah. So just to show an example of how much complexity the first step of transformation reduce. So you can see after removing of all the use case layer, when we only leave with the core and the container classes, we have 26 concept, and with one of the variation, which additional of 18 concept, we only have 44 concept, and that's a reduction of more than 50% of the complexity in this case. Yeah, the next step is to remove the STD variation. So I mentioned those that are not used can be removed. So the one that we're looking at is actually the admissible product variation that we wish to transfer this complexity to the description. So the problem we have is that not all medicinal product will actually generate a admissible product hierarchy. And even when it's generated, they are not used, and therefore we need to know when to generate a description for these cases and when to use it to become as a preferred term. Yeah, so the solution that we have is that we will look at the attribute of the defining dose form that I mentioned, how we select initially, and then look at the attribute if the defining dose form has this attribute admissible dose form, and at the same time the defining strength type of the medicinal product is reconstituted strength, then we will actually generate this additional description, which is the admissible product synonyms, and deem it as a preferred term. And we will use the admissible dose form product term in the description instead of the product term of the defining dose form. So after so this is to show that the difference between the description, whether we use the product term of the defining dose form or the product term of the admissible dose form of the defining dose form. So after removing the use case layer, we are left with the 26 concept. So that's another 1/3 of the concept being reduced. And the third step, which is the removal of the container classes. So for container classes, you can see for these 2 slides, they are actually the same product, but because they exist in different container, so when they exist in different container, it's one of the conditions whether these classes should be generated. So not all medicinal products actually have this SDD class being generated. So our challenge is that we need to determine when to add these additional container attributes into the core classes to represent this group of concepts. Yeah. So the solution is we need to determine when to add the container. So we actually look at the form that we have, which store all the drug information, the container that's within the form, and based on the container, we actually selected the defining container. So based on the defining container, we'll see whether it has this attribute that is create container hierarchy equals to yes or equals to true. So if the attribute is present, then we'll actually create these container synonyms and add the container attributes to the core SDD classes. Yeah, and how to generate these container synonyms, we actually use the product term of the container instead of the product term of the dose form in the description. Yeah, and this is after removal of the container class, and we only have 12 concepts left. And finally, the last step, which is the merger of the SDD classes. We have the quantity and SDD classes that I mentioned is quite similar, but at the same time, we need to determine when to add what group of attributes to the concept when we merge the concepts together. Yeah, and we can do that by looking at which category this medicine product belongs to by looking at the definition, defining those forms. Okay, so for all pack classes, right, we actually will add the quantity attributes, and then we will differentiate the different product, right, based on the pack attribute. So if the defining dose form belongs to a dose form category that's not distinct, we will add the pack attributes to the concept, and that's how we can differentiate in terms of classification. Yeah. So after merging, we'll be left with just 10 concepts in the model, which is our desired model that I mentioned at the start. Yeah. So just to share some of the future work that we plan to do using SNOMED CT. So first is we like to do automation of member assignment for our grouping concepts. So for SDD, we actually manually created our grouping concept and add attribute add data attribute manually. And with those attributes being added, we can actually string them into a ECL expression and then run a query and get the members that we want for that grouping concept. And the next work we like to do is actually to transit from a multi-step publication cycle to a single-step publication cycle. So how we can do that is that we can actually do multiple extraction for different subsets and store them in a reference set. And then we can do validation on each reference set. And if validation pass for all the reference set, then we can bundle them all together and and publish them as one big bundle. Yeah, and lastly, we like to explore a possible integration to the SNOMED CT drug module to enhance possible cross-boundary interoperability in the future. Yeah, that's all for my presentation. Just some take-home message. Yeah, thank you.
Okay, so thank you. Nicholas will now take questions. So as a reminder, if you're in the room, please use the microphone to ask your question. And for those online, please use the Q&A box, but I'm not seeing any at the moment. Do you have any questions? Oh, yeah, this one.
Thank you, Nicholas. Actually, it's quite confused when you're talking about class and concept. Is it the same thing?
No, they are not the same thing. Classes actually are so similar to the virtual medicinal product in SNOMED CT. Different classes contains different level of information, and concept is like so SDD class is like a subset of the concept. So every SDD class is a concept, but just the amount of information contains within that class.
And it seems like in the model that you show, you have both a manufacturer dosage form and the administrative dosage form, or you have only administrative dosage form?
We have both. We have
You have both.
the manufactured dose
Okay.
form and the
And the
administrative
last
dose
question
form.
is that when you said you are compiled to the SNOMED CT, are you using the EDQM term as the standard? EDQM, the European for the EMA.
Not really. So the term that we have is actually derived internally by SDD.
Okay,
Yeah,
so
just that they may have some coincides terms. Yeah.
okay, thank you.
I always have one question. It's kind of obvious from the benefits, there's less complexity, but what other expected benefits do you think you'll get from the enhancement?
Okay, so for reducing the complexity, one of the things that, because we are doing in-house script on our own also to actually generate, to do data extraction. So with the very complex model, we actually, when we do the extraction script, right, it's very complex and we need people who have very deep knowledge in the model as well as the scripting knowledge to actually enable to do that type of extraction. So with a simpler model, we can have so there will be a bigger pool of people who know how to do scripting, to understand the scripting language, but the number of people who actually know the model deep down is actually very limited. So by simplifying the model, we can have a bigger pool of that group of people, and therefore we will make data extraction easier in the way. Yeah, and at the same time, by reducing the complexity, we will have less attribute being generated, less concept being generated. So the performance, the requirement of a tool will also largely reduce, and it will actually increase our performance of our tool by quite drastically. So in that case, operational costs will also reduce. Yeah, and reducing our model, there's also a chance that we can actually publish all our code. Because currently we only actually publish 20% of code due to the advanced complexity, and not all use cases is being used from the planned use cases of the current model. So if we will be able to release all our code, it will be easier for us in a way that we don't need to do any data extraction, any reviews and stuff like that. Yeah, so there's quite a lot of benefit. Yeah.
Okay. Do we have any other questions? Okay, so thank you, Nicholas.
Thank you.
So with that, I'll conclude this session. So online delegates, can you stay here for the next presentation in this stream, or you can access another session through the event lobby. And for those in the room, you've got 2 minutes before we start again.